Welcome back to All This Math. This is Professor Parker. Please make sure you are subscribed to the All This Math YouTube channel. Like the video, drop a comment below, share the video with somebody else that you know. All right. Now, this is a video for youth, for students, young people, middle school, high school, taking Algebra 1. This might be in an Algebra 2 class. It's also, however, for parents. So parents can understand what type of work their children are bringing home so they could potentially help their children with their homework. You know what I mean? So, what are we doing today? We're going to solve a system of equations. Now, you notice there are two equations written here. Equation 1, equation 2, right? This equation has two different variables in it, a y and an x. This equation has two different variables in it, a y and an x also, right? So what we're going to do is we're going to find out the numerical values of these letters or variables that make this a true statement and also make this a true statement at the same time. So it's going to be, so we're looking for two numbers, right? Two numbers that can go in place of x and in place of y in this equation and make this true, and the same two numbers, the same exact two numbers that can go in this equation and make this true. Now, when I say make it true, what do I mean by that? I mean that the left side is equal to the right side, right? So everything adds up, everything's nice and neat, and we squared away and we balanced, right? It's square business, right? Square business, everything is equal, right? Squares have four sides, right? When it's square business, that means we cool. Everything is equal, right? Nobody getting over nobody. Nobody's getting more than somebody else or whatever, right? Everything is equal and everything is cool. So this is a true statement. That means that 3 times some number plus 4 times some number actually is equal to negative 50. And if this is a true statement, that means that y, whatever number that is equal to 2 times some number minus 7, all right? And the same numbers are in each system now, or in each equation. The whole thing is a system, right? Now, when we solve systems of equations, there are typically three methods that we use. Either the graphing method, which we're not about to do right now, where you graph this equation as a line. These are both linear, right? Linear because the biggest exponents you see or that you don't see are a 1, right? So this is y to the first power, x to the first power, x to the first power, y to the first power. Biggest exponent that you, like I said, don't see is a 1, right? So if we graph these, they would be straight lines. So the solution would be the point where the lines intersect each other, right? Just like one street intersects another street. The solution to that system would be the intersection, the corner, right? The corner where people hang out at, right? The corner, it's the hot spot, right? So we're not about to graph though. We're not doing that right now, not in this video. The other two methods are the substitution method or the addition method. The addition method is sometimes called the elimination method, because what you do in the addition method is you add the first equation to the second, which gives you a result of one of the variables gets eliminated, right? We're not about to do that neither. We're about to use the substitution method. Now, why are we using the substitution method? Now, if you're watching this, let me also say this. You should know how to solve systems by graphing. You should know how to solve systems by substitution. You also should know how to solve systems by the elimination or addition method, whichever you want to call it, whichever your textbook calls it, whatever term your curriculum uses. It don't matter, right? You should know all three of those methods. And there's other methods too. There's something called Kramer's rule that deals with matrices, right? And there's other methods too. But those are the three most popular methods that you should be familiar with. Now, why am I using the substitution method? Because it makes the most sense in this particular problem. Why do I say that? Watch this. I already know what y is equal to. I don't know the specific number that y is equal to, but I know an expression that y is equal to. 2x minus 7 is an expression that y is equal to, right? Like I said, I don't know the specific number, not yet. I'm about to figure that out. I'm about to show you. But I know that y is equal to 2 times whatever x is minus 7. Now, in a linear equation, you cannot solve for more than one variable and find the specific number is equal to when you have two different variables at the same time. But if I have one variable only, even if it's written like 2 or 3 times or 4 times or 5 times, I can solve for that. So watch this. Since I know that y is the same thing as, that's what the equal sign means, equal to or is the same thing as, y is the same thing as 2x minus 7. In fact, draw a box around it. I could take this 2x minus 7 and I could replace that y with it. Let that marinate for a minute. This 2x minus 7, I can replace this y with it. Now, the reason I could do that is because y is equal to 2x minus 7. So therefore, This is also, I can, this, if I replace this with 2x minus 7, I'm not changing the value of this equation. I'm changing the variables, the coefficients, and some of the and a constant, but I'm not changing the value of this equation. Now, how does that help me? How does that benefit me? Because like when you study in algebra, don't just try to memorize a bunch of steps. Make sure you know how a particular step is going to benefit you. How is it going to help you get to the answer? Because right now, this has x and y in it. Two different variables. That's a problem. But if I only had one variable, even if it's written a couple times, I can go through and solve in a traditional way. So if I rewrote this equation as 3x plus 4 times this quantity, 2x minus 7 is equal to negative 50, now I got an equation. All of a sudden, I got an equation that only got x's in it. And that's what I want. I either want an equation that only got x's in it, or I want an equation that only got y's in it. That's a key feature. That's a key idea in solving systems of equations. Make sure you know that, because that's why we're doing it. You want an equation that only got one type of variable in it. That's why we use the substitution method. And that's why instead of using the elimination method, I'm going to use substitution, because I could use elimination, but I'd have to rearrange this top equation, and I don't want to do all that, right? This is a straight giveaway. Whenever you're given an equation, and you should like zero in on this and write this down in your notes, whenever you're dealing with a system of equations, and one of your equations is set up like this, where you got x equals some expression, or y, plain old y equals some expression, that's a giveaway. Go ahead and use substitution method. If you got a choice, your teacher might tell you use elimination or addition method. Then you got to do a little work. I mean, you just got to rearrange the equation and then, you know what I'm saying, like, make it do what it do, right? But if it's set up like this and you got a choice, what I would do is go ahead and use substitution method. That's how I'm coming with it. You know what I'm saying? So look, we're going to replace this, and then I'm going to show you. We're going to have all x's, and then we're going to solve for x. And then once we solve for x, then we're going to go back to the first equation and then solve for y. Because all y is going to be is 2 times whatever x is minus 7. And we about to solve for x right now. So watch this. I'm going to rewrite this bottom equation. It's going to become 3x plus 4. Now, instead of times y, I'm writing times this. Instead of times y, I'm doing times this. Instead of times y, I'm doing times 2x minus 7. Everything else stay the same. That's another thing about substitution. A lot of students can't grasp this concept. When you substitute, everything else in the equation stays exactly the same, except for what you're substituting. It's just like when you got a substitute teacher. Everything else in the classroom is the same. It's just it's a different adult in the room. It's a different teacher in the room. All the textbooks are the same. The walls are the same. The ceiling is the same. The floor is the same. The smartboard is the same. The doorway is the same. Everything is the same. The students are the same, right? The only thing that's substituted is the teacher, is the adult, right? So the only thing we substituting is this y, right? This y is getting substituted. The 3 is still there. The x is still there. The plus sign is still there. The 4 is still there. The equal sign is still there. The negative sign is still there. The 50 is still there, right? See, 3x plus 4 times, make sure you put the parentheses, because that indicates that you're multiplying 4 by this whole expression. So then we got is equal to, excuse me, is equal to negative 50. So now we're about to go in. Now we can solve for x, because we got an equation that only has x's in it. I got an x and I got an x. See? All right, so let's clean him up. So we got 3x. Now distribute this 4 to everything inside here, not to the negative 50, because I've seen students make that mistake. The 4 gets multiplied by everything inside the parentheses adjacent to it. All right, so we got 3x plus 8x minus 28 equals negative 50. All right, and then what I'm going to do next is, and you got options. Like I could add 28 on both sides. I could combine like terms. I'm going to combine like terms. This 3x and this 8x. 3x and 8x, they go together. That's 11x minus 28 is equal to negative 50. So 11x minus 28 is equal to negative 50. Now, I want to get 11x by itself first. So I'm going to get rid of negative 28. So then I'm doing plus 28 on the left side, plus 28 on the right side. Got to be balanced. You got to stay balanced, right? If I add 28 on the left, I got to add 28 on the right. Now I got 11x is equal to, what's negative 50 plus 28? So if I'm at negative 50, that means I owe somebody $50. And then let's say I find $28 in my room or somewhere else or in my car or whatever. And then I give that person the $28 because I owe him 50. So I'm like, yo, let me put something on that, right? So I give you $28. Now the question is, I'm still going to owe you money because I didn't pay you the whole 50. but I owe you some more money. So the question is, how much do I still owe you? So that means I'm going to owe $22. Owe 22. So that's negative 22. I got 11x equals negative 22. How do I get x by itself? Get rid of this 11. How do I get rid of this 11? Do the opposite operation for what the 11 and the x are doing. What are they doing with each other? They multiplying by each other. 11x by definition means 11 times x. 11x means 11 times x. So what's the opposite of times? What's the opposite of multiplication? It's division. You have to know that. So you divide by 11. Boom. Keep it balanced. If I divide by 11 on the left, I'm dividing by 11 on the right. Boom. 11 divided by 11 is a 1. 1x is just x, and I got x isolated by itself. Negative 22 divided by 11 is negative 2, not positive 2. A negative divided by a positive, these are arithmetic rules, always equals a negative. So we got negative 2. So now we halfway done. We're not finished. Remember, this is a system. It's got two equations with two variables. This is not in just a single equation. We know what x is. So now we go here. Now watch how easy this is. Watch this. Watch this. So y is equal to 2 times whatever x is minus 7. So that means I'm doing 2 times negative 2 minus 7. Order of operations. Do not do negative 2 minus 7 first. Don't do that. Come on. Don't do that. Don't do that. You might be tempted to do it. Don't do that. So we got to multiply first, then subtract. Negative 4 minus 7 is negative 11. Now, we think that y equals negative 11. You should always check your work. Always check your work. So now, we already know it's true for this equation, but we got to make sure that these two numbers give us a true statement for the second equation, right? But let's go ahead and check the first equation too. So is negative 11 equal to 2 times negative 2 minus 7? Yes, it is, because that's negative 4 minus 7. All right, so we know it works for the first equation, but the key is you must make sure that both numbers work for both equations. You must make sure that both numbers work for both equations. And when you graduate to the systems of equations with 3 equations in it, don't be scared, right? You're going to have to check all 3 equations, right? Now, let's check this one. 3 times negative 2 is negative 6. 4 times negative 11 is negative 44. Now, is negative 6 plus negative 44 equal to negative 50? That's the question. It is. Negative 6 plus negative 44 is equal to negative 50. So that because these numbers give us a true statement, that means that they are correct. Because in math, we're looking for the truth. In math, we are looking for the truth. So if our numbers that we arrive at give us the truth, then that means that they are correct. When the numbers give us a lie or a falsehood, that means that they are incorrect. It's that simple. Keep that in mind. In math, we're looking for the truth. All right, so how do we write our answer? You could leave it like this and just do x equals negative 2 and y equals negative 11. Always draw a box around your answers. Or you could write them like a set of coordinates on a coordinate plane. You can write, and they always go in alphabetical order. So the x goes first, the y goes second. So you can say negative 2 and negative 11. That's another way to write your answer. All right, see, alphabetical order, x first, y second. So that's just a little introduction to solving systems of equations using the substitution method. The substitution method. We didn't use the addition/elimination method. We didn't use the graphing method. We didn't use Kramer's rule with matrices. But this is the substitution method. And once again, why did I use the substitution method? Because it's more efficient and it's easier to use that when the system is set up like this. Whenever I already have a variable that is already solved for, right? Not in terms of you knowing the specific numerical value of the variable, but an expression that the variable is equal to. If I know an expression that the variable is equal to, then I could just take that whole expression and just plug it in or substitute, hence the term substitute. See, everything in math is called what it's called for a reason. One of the things you should do as a student is make sure you understand why is it called that. Like, why is it called that? Like, why we call it that, right? It's like etymology, right? It's like etymology in a language. Like, where do words come from, right? So why is this called substitution? Because in this method, I'm substituting this expression for a variable in the other equation. That's what I'm doing. All right. So we do that. Then we create an equation with the same variable in it, even though it's written a couple times, it's got the same variable. So that means I can go through the steps and solve for that one variable, right? And get a specific number. And then I take that specific number, throw them in the first equation and figure out what the other variable is, go back and check my work, and we done. All right. So go get some practice with these. And I'll see y'all on the next video. Peace.